October 13th, 2023 marked a historic moment in spaceflight. SpaceX's Mechazilla arms gracefully caught their massive super heavy booster mid-air, a feat that left the space industry in awe. This wasn't just another rocket landing. It was a glimpse into the future of rapid rocket reusability that could revolutionize our journey to Mars. But halfway across the world, this achievement sent ripples through China's aerospace sector. Within weeks, Cosmo Leap, a Chinese startup founded just months earlier, secured $14 million in funding to build their own version of SpaceX's catching system. Their blueprints? Remarkably familiar. So familiar that even Elon Musk couldn't help but comment, "Look familiar." This isn't just about catching rockets. It's about the race for space dominance. As SpaceX pushes the boundaries of what's possible, China's private space companies are watching, learning, and moving fast to close the gap. But in the complex world of rocket science, copying the design is one thing. Mastering the technology is another entirely. Welcome to Elon Musk 24 Hours, where today we're diving deep into China's ambitious plan to replicate SpaceX's groundbreaking technology, the challenges they face, and what this means for the future of space exploration. Let's dive right in. Let's start by examining what makes SpaceX's Mechazilla system so revolutionary. This isn't just a pair of mechanical arms. It's a precisely choreographed dance between rocket and machine. The system uses advanced AI-driven algorithms to track the booster's descent, adjusting for wind conditions and atmospheric variables in real time. Each catch requires accuracy down to centimeters, with the arms moving at exactly the right moment to cradle a 230-foot rocket traveling at considerable speed. Cosmo Leap's Imitation project shows remarkable ambition in trying to replicate this feat. Their newly revealed plans showcase a system they're calling the Dragon's Embrace, a clear nod to their determination to catch up with SpaceX. The specifications are telling: a 75-meter rocket with a 4-meter diameter, powered by 9 engines in an octagonal configuration. Sound familiar? It should. It's practically a blueprint of SpaceX's successful formula. But here's where things get interesting. Cosmo Leap isn't just copying. They're attempting to innovate in their own right. Their offshore launch platform concept, while similar to SpaceX's ocean platforms, includes some unique features. They're developing a stabilization system they claim can handle rougher seas than current technology allows. The platform is designed to be semi-submersible, potentially offering better stability during launches and catches. However, the technical challenges are immense. Let's break down what Cosmo Leap needs to master. First, there's the propulsion system. While they're using methane fuel like SpaceX, developing reliable engines isn't simply about following a recipe. SpaceX spent years perfecting their Raptor engines through countless tests and failures. Cosmo Leap's timeline of achieving this by 2025 seems optimistic at best. Then there's the control system. Their Firestone #1 flight computer and Little Firestone recovery tower controller need to process thousands of variables in milliseconds. SpaceX's success comes from years of accumulated flight data and real-world testing, something Cosmo Leap can't simply download or reverse engineer. The recent struggles of other Chinese space companies highlight these challenges. Deep Blue Aerospace's September crash of their Nebula 1 rocket shows how even small miscalculations can lead to catastrophic failures. Space Pioneer's Tonglong 3 explosion during static fire testing demonstrates the dangers of rushing development. But here's what makes this story fascinating. Cosmo Leap's $14 million funding round shows China's serious commitment to catching up. This isn't just about rockets. It's about technological independence and space sector dominance. Their investors, including heavyweights like Shenzhen Capital and notable investor Zhang Chao, are betting big on closing the gap with SpaceX. The numbers tell an interesting story. Cosmo Leap's Yuechan aims to lift 10.45 tons to a 1,000-kilometer orbit in expendable mode, or 6.28 tons in reusable mode. These capabilities mirror the early Falcon 9, but achieving them requires mastering countless technological challenges. Grid fin navigation systems that can withstand extreme temperatures, and forces precision landing algorithms that account for varying atmospheric conditions, advanced materials that can survive multiple re-entry cycles, real-time communication systems with minimal latency, sophisticated thrust vectoring control for precise maneuvering. Their ambitious roadmap includes an even larger 126-meter rocket by 2030, capable of launching 100 tons to orbit in expendable mode. This would put them in direct competition with SpaceX's Starship, if they can pull it off. The competition has already sparked innovation. Cosmo Leap's engineers have developed a novel approach to the catching mechanism, using what they call adaptive grip technology. This system supposedly adjusts its catching force based on real-time telemetry data from the descending rocket. An interesting variation on SpaceX's design. But perhaps the most telling aspect is the speed at which this is all happening. Within weeks of SpaceX's successful catch, Cosmo Leap had not only secured funding, but had already begun construction on their test facility. They're moving fast, perhaps too fast. History shows that in rocket development, haste often leads to costly failures. Other Chinese companies are watching closely. Landspace's success with their methane-powered Zhuge 2 rocket shows that China's private space sector can innovate. But as companies like Galactic Energy and CAS Space have learned, success in this field requires more than just copying designs. It requires building a foundation of technological expertise from the ground up. The crucial question isn't whether Cosmo Leap can build a rocket that looks like SpaceX's. It's whether they can develop the deep technical understanding and operational experience needed to make it work reliably. SpaceX's success comes from thousands of hours of testing, hundreds of iterations, and a culture of learning from failure. As we stand at this pivotal moment in space exploration, one thing becomes crystal clear. While imitation might be the sincerest form of flattery, true innovation requires more than just copying blueprints. SpaceX's decade-long journey to perfect their rocket-catching technology wasn't just about engineering. It was about building a foundation of knowledge through trial, error, and relentless iteration. China's space ambitions through companies like Cosmo Leap represent more than just competition. They're a testament to how SpaceX has fundamentally changed the game. Whether their $14 million gamble will pay off remains to be seen, but one thing's certain: the race to master reusable rocket technology is pushing the boundaries of what's possible in space exploration. What do you think about Cosmo Leap's chances of success? Drop your thoughts in the comments below with Mission Possible if you believe they'll succeed, or Mission Critical if you think they're moving too fast. Your insights help make our space community stronger. If you've enjoyed diving into this analysis of the global space race, make sure to hit that like button and subscribe to Elon Musk 24 Hours for more in-depth coverage of SpaceX, space technology, and the future of space exploration. Hit the notification bell to stay updated on the latest developments in this fascinating story. This is Kevin, signing off until our next space adventure. Keep reaching for the stars.